So, if you look into this pin diagram of 8051, so this is that pin diagram. So, 8051, so it is similar for 3151 and 8951 also. So, so more or less we have discussed the pins. So, we will see it in more detail in the successive slides. The important pins are like this. The first of all, the most important feature of 8051 is that it has got 4 I/O ports, and for that matter if you look into any microcontroller, since the microcontrollers are talking to the environment. So, these I/O ports are very important parts in them, and all microcontrollers they will have some I/O port integrated into them. So, in 8051 there are 4 such I/O ports marked as P0 to P3. Port 0 they occupy the pins 32 to 39 of the processor of the chip, and they are called P0, and it is they are also written as P0.0 through P0.7. The way we are writing it as P0.0 through P0.7 because of the fact that these bits these ports are bit accessible. So, you can control individual bits separately. Okay. So, that is why we write it as P0.0, 0.1 like that. So, on the other hand, so in case of say 8085, so we have to write in port and then the data is 8 bits only. So, whether you use those remaining bits or not, so that is up to the program, but the system gives the 8085 processor will read the 8 bit pattern, or when it is outputting it will output an 8 bit pattern. So, this port 0 is 8 bit read write operation. So, for general purpose I/O, or it can act as multiplexed low byte address and data bus for the external memory design. So, if you have external memory, then we have to use this multiplex. So, this port 0 bits for the multiplexed address data bus, okay, lower order address and data bus they are multiplexed like that. Then we have got port 1 or P1. So, this P1, so this is clear. So, P1 does not have any other function multiplexed into it. So, if in your design if you want to use some port, the first option is to go for the port P1, because here no other function will be multiplexed. So, there should not harm any other system operation. So, 8 bit read write operation, and again it is general purpose I/O. For port 2, so this will occupy pins 21 to 28 and written as P2.0 to 2.7. So, again this is multifunctional. First of all, first one function is the 8 bit read write operation for general purpose input output, or it also provides the higher order address bits for the external memory design. So, this port 0 was giving us the lower order address bus and the data bus, and this port 2 is giving us the higher order address bus. So, for memory connection, so we have to use port 0 and port 2 pins. Then port 3, so this is again multiplexed. So, this is for it is so it has got many functions. So, it is general purpose I/O. So, if not using any of the internal peripherals, timers or external interrupts, then it is okay. Otherwise, so they are to be, we have seen previously that they are the read write operations, the read bar, write bar pins and all those things are there. So, this is also multifunctional. So, as we have seen previously, like in this diagram you can see that P 3.0 is receive data, 3.1 transmit data, then this interrupts, then T0, T1 the timers, then write bar, read bar. So, they are also multiplexed onto this port 3. Each port can be used as input or output bidirectional, and that is also it is bit controllable. So, you can do to control at the bit level, maybe one bit is configured as input, other bit configured as output. So, that is possible. So, this is the summary of port 3 alternate function. 3.0 is receive serial input data, 3.1 is serial output data. So, this we have already discussed. Now, port 3 bit latches and I/O buffer. So, this is the structure of a particular port bit. Okay. So, you see that every port bit, so this 3.x, so this is the pin. Okay. So, from the pin the line comes and it goes through this direct, ultimately connected to the internal bus. So, it is connected like this, but in between there are many other things. So, there is a latch here, Okay. So, from the data bus, whenever you are outputting some data, so you can put into this latch. As a result, until and unless you are writing something new onto this latch, this the processor need not bother about what value it has to output onto the pin. For example, for turning on one LED, the LED may be connected from here and the processor may write a 1 here. As a result, this LED is turned on and that LED so remains on. Okay. So, even if the processor is doing something else, as long as it is not writing a new value 0 to this latch. So, this point will this Q output will be at 1. As a result, this value will be at 1. So, if this Q output is 1, you can understand that this NAND gate output will be 0. So, this transistor will be off. As a result, this 1 value will be coming here and the LED will be on here. So, this way we can have this thing. Then otherwise we can have, so when but for the input part, so there can be two cases. One is you can read the content of this latch or you can read the content of this pin. So, accordingly we will find that there are separate instructions for reading latch and reading pin. So, if you are trying to read the pin, then this control has to be enabled. As a result, this pin content will be available onto the bus. If you are trying to read the latch, then this read latch control has to be activated. So, this will be coming here and going to the latch. And of course, so other thing, the alternate input function and alternate output function. So, these are actually the other alternate functions that we have, like providing read bar, write bar, etc., or this transmit, receive. So, all those port 3 alternate functions that we have. So, they can be connected to these pins, okay, these lines, alternate functions. So, we will see some example about how this pin structure is going to work. So, this is the diagram that we had previously. So, each pin of the IO port, so it is internally connected to the CPU bus. So, we will take some example like how to write a 1 to the pin, say 1.x. So, this is the port 1 and we want to write a 1 here. So, how to do it? So, we can just we can write a 1 here. So, to write a 1 to this pin, so we put a 1 here. So, this D flip flop, this D latch will be, so and this write to latch. So, this signal is activated. So, this D bit becomes 1 and so this bit becomes 0, this Q bar becomes 0, Q becomes 1, Q bar becomes 0. When Q bar is 0, so it is connected to this transistor, gate of this transistor. So, gate of the transistor getting 0, so this transistor is turned off. So, if you measure the voltage at this point, so you will get high. So, accordingly you will get a 1 at this point. On the other hand, if you are trying to write a 0 to the output pin, so you write a 0 here. As a result, Q value becomes 0 and Q bar becomes 1. When Q bar becomes 1, then this transistor gate is on. So, this transistor is on. As a result, at this point you will get the voltage of 0, because this transistor is on. So, you will get a 0 at this point. So, at the pin you are getting a 0. So, you see, by writing the value of the internal bus into this latch, so ultimately the pin is getting affected. So, that way we can do the output operation onto the pins. So, first to write 0 to the pin, so first we do this. So, 1 goes to the pin, then we output the output pin is grounded, because this gets a 0. So, this is 1. So, this is this becomes off, this becomes on. So, this pin gets grounded. Okay. So, this is how this is taking place. So, this value is 0, this value is 1. So, that will be getting a 1. On the other hand, if you are trying to read an input pin, okay. So, when you are trying to read an input pin, so we have to set this read pin value to 1. So, first of all, okay, so we have to read this, we have to put this pin value to 1. So, if this pin value to 1, so value that we have here will be coming at this point. Okay. But there is a catch here, because suppose the value that we had previously put onto this D flip flop is say 0. Okay. So, D flip flop previously this latch was equal to 0, the Q was equal to 0. So, Q bar was equal to 1. As a result, this transistor we had a 1 here. So, this transistor was on. So, it is not off, it was on. So, whatever value you put at the input pin, whatever voltage value that you put at the input pin. So, if you measure the voltage here, you will get a 0. So, as a result that 0 will be coming to here. So, even if this input pin is set to 1, because previously this latch was set to 1, okay. So, this value will be coming to the previously this latch was value was 0 and Q bar value was 1. So, you will be getting a 0 at this point. So, if this previously this value was 0, this value was 1. So, you are getting a 1 here. So, this transistor is on. As a result, even if I want to get a 1 at this point, this 1 will get discharged by this path and this 1 will be modified to 0. So, whatever be the value that you put here, so when you give this read pin signal here, so you will be getting a 0 at this point. Okay. But the value that I have put there is 1. So, how to do that? So, for doing it, so what we need to do is first write a 1 to the pin. So, first we write a 1 to this pin. So, if we write a 1, then this value becomes 1. Okay. So, this latch becomes 1. So, this Q bar becomes 0. As a result, this transistor is turned off. So, now this voltage value at this point cannot be discharged by this transistor. So, if you put a 1 here at the input pin, then when you are doing this operation, that is reading the pin, so this value will be coming here and it will come to the internal bus. And similarly, if the value that you put here is 0, so that way that 0 will get transmitted via this latch and it will be coming faithfully to this bus. So, make it a rule that whenever you are trying to read from an input port, first you write a 1 at that port. So, this is the rule, write a 1 to the pin. So, by executing the instruction move P1, 0 FFX. So, here all the bits of port 1, so they will be configured as input port, input bit. So, now after that you can do a read operation. So, this is the first thing that we have to do. So, when you do this move A, P1, so then they will be so the external pin will become high and then you can get the value of this port onto this A register. Otherwise, this will not happen. So, any point you are trying to read the content of a port, first you write 1 to the port. So, it may be to the bit or maybe to the entire port depending upon your application, but that has to be done. Reading low, of course, there is no problem, because even if this gets discharged, so there is no issue, like you are anyway giving a 0 here. So, it does not have any issue, but still since we cannot predict like what is the next value that we are going to get from the outside pin. So, irrespective of whether you are reading a low or a high at the next point of time, since we do not know that in what is going to happen in future. So, it is advisable that before any in operation, before any read port operation, you do a write port with the value 0 FFX if you want to do it for the entire port, and if you are connecting only a single line, then a single bit, then you set that bit to 1. So, this is the reading for input for the port operation, we have to be a bit careful. Port 0, so it has got some additional feature. So, this is basically an open drain port. So, you have got this, so you need to connect these external resistances to port 0. So, 10 kilo resistances are to be connected. So, they are actually open collector type of connection or open drain type of connection. So, you should connect these resistances externally. So, this is helpful because if you want to drive some high load from port 0, so you can do that. Otherwise, if you are doing it from other ports, so this the drive current is limited. So, you cannot drive a high current through that. So, if you want a high drive current, so you can have this, you can connect the device to port 0 and through this pull up resistors, and as a result you can put high current onto those ports or those devices. Next important pin that we have is the PSEN or the program store enable. This is the read signal for the external program memory and it is active low. So, we will generally call it as PSEN bar. So, we will call it as PSEN bar, telling that this is a active low signal. So, this is similar to the ROM interface. So, if this is your 8051 and you have connected the external ROM here. So, for the ROM I will have that read bar line. So, that read bar line it should be connected to the PSEN bar line of the 8051. Okay. Then, so that is there. Then we have got the ALE. So, address latch enable to latch the address of address outputs of port 0 and port 2. So, this is port 2 is of course no problem, because port 2 is the higher order address bus and that is fixed, but this lower order address bus. So, it contains multiplexed with the data bus. So, just like 8085, so we have got this multiplexing. So, here also we can have a multiplexing of this address bus, lower order address bus, demultiplexing of the lower order address bus by putting some external latch. Then this external access EA. So, this is again an active low signal. So, this is also EA bar, you can say is also EA bar. So, external access enable. So, if you want that if you want to access external memory, then this EA bar line should be made low, and if you are and if you are trying to access only internal memory, then this EA bar line will be made high. So, we will come back to this again later. Then there is receive data and transmit data. So, these are the universal asynchronous receiver transmitter operation that 8051 has integrated with it. So, these are the pins on the serial IO on port 3. So, TXD and RXD pins. Then we have got the crystals, okay, for crystal oscillator we have got the external pins. Then we have got VCC. So, VCC is the supply voltage which is plus 5 volt. Then we have got the ground pin 20, which is the ground pin. Then the crystals we have got XTAL 1 and XTAL 2. So, they are providing external clock. So, you can use a quad crystal oscillator or you can use a TTL oscillator. So, you can connect some crystal oscillator here and get the frequency. So, it can also be a crystal TTL based oscillator. So, that can also be connected. So, from external source, in that case we do not connect anything to the XTAL 2, but in XTAL 1 we connect the oscillator output, okay, and this is grounded. So, we can find out the machine cycle for 8051. So, it is like this, that the crystal oscillator may be, say, in one case it is say 11.0592 megahertz. Then one machine cycle is to get a, so the internal clock that it has is 11.0592 divided by 12, that is 921.6 kilohertz, and so one machine cycle is 1 upon 921.6 kilohertz, that is 1.085 microsecond. So, in this case if the crystal is 11.0592 megahertz, if it is 16 megahertz by the same operation, so it is internally it is divided by 12. So, you get 1.333 megahertz, and so machine cycle becomes 0.75 microsecond. So, this divisor of 12 is fixed. So, whatever crystal we connect, whatever frequency it is generated, it is divided by 12 to get the internal machine cycle frequency. Then we have got some more pins, RST or reset pin. So, it is active input pin and it is active high. So, normally it is active low, but we must hold it for 2 machine cycles for getting it active as sensed. Okay. So, that is the active, that is the reset signal, and also this is also the power on reset is there. So, when we power on the system, so it will be a reset. So, if you apply a high pulse to the reset line, then the microcontroller will reset and the values of all the CPU registers will be lost. Okay. So, that they will be some of the values will be reset. Okay. So, we can have some power on reset circuitry for doing this operation. So, this is the power on reset circuitry. So, this is when this button is pressed. So, this is the manual reset. So, if you manually reset it, then this capacitor will get charged, and accordingly we can. So, this capacitor will this will get discharged, and there will be one pulse coming here. So, that will be giving as reset signal, or when it is switched on, then also the capacitor slowly gets charged, and accordingly we get this pin, this power on part. Some of the values of these registers that we have in 8051, for the on reset, the program counter will get 0, accumulator register is there, which is also become 0, B register will become 0. So, all these registers PSW they become 0. The stack pointer is 0 is 7, and this DPTR register. So, this will become all 0, and the entire RAM content will become cleared. So, this is the special we will look into these registers once we go into the register file of 8051. So, we will see them, but their contents will be like this when the reset is done. And interestingly, the RAM, which is the 128 byte RAM that we have in 8051, or for that matter the other processors, other family of processors. So, their RAM content will also be cleared. So, that will ensure that the scratch pad is clear. So, the entire RAM is basically a part of the processor now, we can say, compared to the general system where the content of the RAM is not predictable, it can contain any garbage, but here the RAM contents are cleared by the processor. So, it is all 0. Then this EA bar pin, so or external access. So, there is no on chip ROM for 8031 and 32. So, for them we can have this EA bar pin connected to 0, because there is no ROM chip present. So, it has to be external memory, and so in those cases, so it is connected to ground to indicate that the code is stored externally, and this PSEN bar and ALE. So, they are external. So, they are used for this external ROM access. So, PSEN bar will be, as we have said, that PSEN bar will be connected to the read bar line of the ROM, and the ALE is for demultiplexing the lower order address bus and data bus. For 8051, EA bar pin is connected to VCC. So, because 8051 has got internal ROM. So, when the system comes up, so this EA bar pin, so this the program will be started from the internal ROM. So, that way this EA bar pin should be high, so that it does not go into the does not go to access the external memory immediately. And this PSEN bar is the program store enable. So, again this we have already said, this is connected to this OE bar. So, OE bar is the output enable bar, which is same as the read bar pin that we are talking about. So, in case of ROM, so instead of telling that it is a read bar, so we normally the pins are normally identified as output enable or OE bar. ALE is the address latch enable. So, just like 8085, so this is there. So, it is an output pin and an active high. So, it provides port 0 provides both address and data, and ALE is used for demultiplexing the address bus, just like the demultiplexing we did for 8085. So, typically a latch like 74373 can be used, and this 74373 has got a G pin, which is actually the latch pin, you can say. So, this ALE can be connected to G. So, when this G is high, then whatever is in the input, so that value is latched onto the 74373 latch. Okay. So, this is the multiplexing for external memory. So, this is the A0 to A15 address and D0 to D7 date. So, this is the non multiplexed access. So, total 24 bit. So, when the multiplexed access, this AD0 to AD7, so they are A0 to A7 and D0 to D7 are multiplexed. So, in the first part you provide the address for the lower order address byte, and in the second part we get the higher the data part. So, that way the number of pins reduced from 24 to 16. So, as we were telling that this port 0, the higher order address bits. So, that is port 2 has got the higher order address bits A8 to A15. Port 0, the data bus will be coming connected. So, data bus is connected D0 to D7, and the address bus lines A0 to A7 are multiplexed with D0 to D7. So, they are also available here. So, for that it is connected to this 373, and this ALE signal. So, it is connected to the G pin of 373. So, in the initially when 8051 puts the address onto the address bus, the higher order address bus contains the higher order bits, lower order address bus contains the bits A0 to A7, ALE signal is given. So, the value gets latched onto this 373 latch, and after that this ROM will this PSEN bar line is connected to the OE bar line of the ROM. So, as a result the ROM will put the data onto the data bus, and this they will come to again the port 0 of 8051, which is acting as the data bus for the 8051, the external data bus for the 8051. So, in this way, just like 8085, so here also we have got multiplexing of address and data bus, and it can be connected through the latch.